All right. You see this toolbox right here? So right triangles are your best friend. Here's a big hint. If you don't have a right triangle, just today here. Ready? We're going to do 2 more different ways to get right angles in a circle. Just fill this out right here. Bisect. Yes. If perpendicular, then bisect. If perpendicular, then bisect. Say it with me. If perpendicular, then bisect. Ready? Go like this with me. Say chord. If a radius is perpendicular, what does and this is true of a diameter as well. Okay, so it's true of a diameter. So go ahead and trace the radius, and let's make it perpendicular. And if that radius is perpendicular, it also bisects that chord. And when I say radius, it can also be a diameter. If perpendicular, then bisect. The converse is also true. Okay, take the A and now draw in a radius. Go right through the middle. If a radius bisects the chord, automatically it's also perpendicular. And that's where you get that hidden if perpendicular, then bisect. If bisect, then that's right. If perpendicular, then bisect. If bisect, then perpendicular. There's also one more extremely subtle right angle. Extremely subtle. Okay, this red, you don't need to write it down, but I just want you to read it. Okay, I'm going to write chord, actually do write it down. Write chord BC is, you're writing this in your reference booklet, 5 centimeters from the center. I'd like you to physically label that little sentence on your diagram. Physically label it. That's a sentence. Label your diagram. Chord BC is 5 centimeters from the center. Alrighty. Let's see if you did this correctly. How many of you did that as 5 centimeters right there? Raise your hand. Okay, question. But that has 2 qualities. Quality number 1, that distance segment also bisects the chord, and it's also perpendicular. Just out of curiosity, how many of you actually marked both?
I did it.
The rest of you. Code. When you see problems that talk about from the center, automatically that means distance. That means there is a right angle there. And it's bisected. You ready to go? Go to today's notes on the front. We're going to do 3 problems together. Today's notes on the front. We're going to do 3 problems. No, sir. We will not do them all together. Yes, turn on the lights. Right, you need your calculator, Sandy. Go to the front page, please. Front page. Front page. Get your calculator, Sandy. Yes, this time and this time only. I'll let you have your cell phones, but guys, you really need your own calculators. Okay. Yes, sir, you may. Alrighty. Let's recap. Prior lesson, we have only two ways to get right angles. The first one is I'd like you to sweep, please, 180. And now I'd like you to draw an inscribed angle, EHG. Draw an inscribed angle, EHG. This was the first way that I All righty, guys. Now, take a look. We learned if you inscribe in a half a circle automatically, that makes a right angle. Put a dot there where it says radius. Put a dot. Now, draw in a tangent. That's why you have a postcard. I want you to use a straight edge. You have a postcard because I want you to use a straight edge. Okay? Sarah, could you start that fan, please? You have the fan right behind you. Ready? Trace and sing with me, folks. If tangent to a radius, radius of tangent to a radius, right angle at the edge. So, tangent. Okay. Ready? Remember the word distance. The code phrase for distance is from the center. The code phrase for from the center is distance. All right. Let's do 3 problems together. Ready? I'd like you to take that little paragraph. I want you to read it and label it. Don't figure anything out. Just read it and label it. Go. Read and label. Go. Let's see if you label properly. It's okay. Okay, let's see if you label this properly here. Okay, so we have both chords are 8 units. Notice the phrase from the center. That means that from the middle, right there, it smacks it at a right angle and creates a hatch mark. Smacks it at a right angle and creates a hatch mark. So as the 8 units, so this is 8 and this is 8, and here's a simple concept. If the distances are the same, then the chords are the same length. Okay. Now, you're supposed to draw in the radii, so let's see if you put those in the right place. So we have a radii here, here, and here. How many of you got the radii in the right place? You did? Okay, now we're ready to go. We want to find the length of the radii and all angle measures. Because from the center, what kind of triangle do we've got going on here? Let's pull it out. That's 8. We go like this. If perpendicular, then bisect. That's 6. It's not drawn to scale, obviously. Ready? I'd like you to find the radius, which is the x. Go. Pythagorean theorem. If you have 2 sides, you need a third side. Okay. That's why you that's you don't look at 12. 12 the whole thing now. Okay. Ready? All right. Miss Coleman, what you got for X? 10. Yes, because you end up with X squared equals 100 square root. Okay, we've got 10. That's this 10. That's this 10. We now have all the segments. What are we missing? Arcs and angles. Okay, so let's see what we can do here. Measure of essential angle to the right. So we do this. And that means this is how much? 146. All right. Now, since those triangles are congruent, in which they are, let's swing this around. I like you to find the giant arc, the blue. Go. The giant blue arc. Giant blue arc. Claire, what you got? Uh-huh. So that's 214 away from 360. All righty. And then, because these guys are equal, okay, we know they're equal and they meet, then we can take the 214 and split it up. So that means from here to here is, and from here to here is also 107. All right, I'm going to freeze it. I want you to find every other possible angle. Take your angle measures to the 10th place, folks. And why? Okay. Zoe, what do you need? How do I split it? Why did I know that was congruent? Okay. Do you see how the chords are equal length? If the chords are equal length, then the arcs are also equal in length. That was in last night's videos. If the chords are equal length, the arcs are equal length. Okay, guys, you do your own math. Find every possible angle. I'll show you the answer in about 30 seconds. See if you can do this on your own. All right, guys, ready? Check. You guys got it? It's 53.5. How did I get that? How about this? I'll make it bigger. It's because it's 107 cut in half. Because measure of a central angle to its arc the same. So this angle right in the middle, all right, would have been 107. All right, let's do another one. I'm going to give you guys a shot at extra credit. Turn to the next page, please. Next page. Okay, take a close look at this diagram. Question to you. At this moment, right now, do you see any triangles? Right now. No, triangles. Right now, do you see any triangles? Big hint if you don't see a triangle. Try to make one. I like you to draw two radii so you end up with two. Drawing two radii so you end up with two triangles. Okay, your 10 is here. Yes. So where the 10 comes goes here, all the way. That goes this, that. That's okay. Let me do. Opposite adjacent hypo. Alrighty, guys. You should have drawn in from here to here. Now, find the length of those radii. Go. You have 10 seconds, literally. I will allow someone in 10 seconds. Find the length of those radii. Do not say that loud. Find the length of radii. Hannah, what's the length of our radii now? Yeah, guys, if you're touching your calculators right now, you're working way too hard. Watch, guys. Remember I told you guys to trace all radii? Good. Can you trace the 17, please? Is that a radius? Okay, what about over here? That's a radius too. Oh, you didn't see it because you didn't trace it. Okay, so this right here is 17. This is also 17. Thumbs up if you actually got 17. That's only about, more than half of you. Excellent. Looked like you were working very hard. All right, now, this X, I'd like you to squiggle it. X is only from there to there. It's not the whole segment. Okay? I want you to find everything possible, so let's start with this right triangle. I'd like you to, right here, squiggle this, call it Y. Now do you have a right triangle? Okay, let's pull it out. Solve for Y, round to the tens place, go. Solve for Y, round to the tens place, go. Solve for Y, round to the tens place, go. All righty. Ready. Zoe, what'd you get? You may use your phone. Okay? You can use your phone. What'd you get? Yes. 5.7 it is. Okay, so we just found the Y, 5.7. Okay? Yep, and then this over here is 16. Ready? I want you all to find X now. We're finding X. And Anthony, what'd you get for X, buddy? Okay, can you tell me what math you're doing? Let's do something together. You ready? Track along with me. Step number 1, from the center, could you trace a radius, physically trace a radius? Do you see that red's a radius? What's that length, sir? The radius is what length? Physically, from the center to the edge. Because it's the same here. It's a spoke and a wheel. Ready? Can you physically trace the 5.7? Physically trace the 5.7. Now tell me, how are you going to get the green? Okay, can you physically trace the 17? Do you see the 17, sir? Trace it. Okay, so that's 17. From here to here is 5.7. Okay, I want this. Yes, can you subtract, please? And then get rid of your gum. Fabulous. Mr. Mullis, what'd you get for the green? Okay, thumbs up if you got 11.3, folks. You got it? Okay. Have we found everything? What have we not found? It's 11. It's 11. It's 11, right? 11.3? Yeah, it's 11.3. Okay, what do we not have here, kiddos? We have no angles. So back to our triangle here. Back to our triangle. That is a central angle. Measure of a central angle to its arc. Excellent. So that angle is right there. That's theta. Okay, this here is our opposite. That's our adjacent. And here is our hypo. Do you notice we have all three? So we could use inverse sine, inverse cosine, or inverse tangent. I tend, given a choice, I tend to just use inverse sine. Ready? Let's do inverse sine. Find me that angle. Okay. Aaliyah, what'd you get for the angle, ma'am? Then I'd like you to do it. Inverse sine 16 over 17, please. Okay. Kavir, what'd you get? Okay, we're going to run it to the nearest whole degree. So what is it? 70. So up here is 70, which means over here is 70, 70. Last but not least, find the yellow. Go all the way around, find the yellow, and we're done. There's a lot of work, right? So all right, triangles. Yes, ma'am. These guys? Because we have no diameters. Oh, the little guys. We should. You are so correct here. So technically this is, are you talking about those guys? Nicole? Good call, dear. I overlooked them. Nice job. Okay, swing into your teams, touch your desk. Swing into your teams, touch your desk. He's in the middle team. He's in, all right. Swing around, touch your desk. This is your team problem. You have 7. Possible. Ready? Okay, you are texting, you're not doing math. So, stop right. Technically, he's there. Isaiah, can you focus there? Because technically, you're supposed to be over here. All right, fine. All right, students, you have 7 minutes. Read, show me all your work, and then I will check.